Hello my dear students and my dear friends. Today we are in a new topic. Okay, first of all, before declaring the topic, I should request all of you that here you see, here it is not necessary that you will learn only the questions from the exercise. Conception is very essential. For this exercise 7.2, at first if you do not understand this concept, then this just you cannot understand the exercise. Okay, so the concept is very important. This is my observation that in the last videos, whatever video I uploaded, there wherever these conceptual videos were there, their views are very less, because you do not observe, do not watch those videos. You directly move to the questions. Okay, so directly, if you cannot understand the question, if your knowledge about the topic is zero, so please try to watch it nicely. Okay, here conception is very much essential. Okay, here let us move to the topic, trigonometrical ratios of a plus b, or the addition formula. Here today we shall do the formula like sine of a plus b, cos of a plus b, and tan of a plus b. Let us go for these three. Okay, so at first let us draw the diagram for it. For the case of simplicity, we will draw the diagram in the first quadrant only. This is x-axis, this is y-axis. Okay, this is the origin. Now let us consider that with respect to this x-axis and rotating arm, suppose this is r1, it makes an angle a1 with respect to this x-axis. It rotates like this, so an angle a is formed. Let us take a. Then from this arm another rotating ray we consider. It rotates like this. Suppose this is r2. Suppose this angle is b. Here again I am explaining. With respect to this, an arm rotates, a ray rotates like this. What is the angle formed at O with respect to x-axis? Angle is a. Then from this ray another ray rotates through an angle b. So this total angle is a plus b. This angle is a plus b. Today we are going to find sine of a plus b, cos of a plus b, and tan of a plus b. Okay, for this what we do, from here let us choose any point. It is not necessary that you choose here or wherever I have given. You choose a point P. Okay, on OR2 you choose a point P. From there let us draw a perpendicular. Suppose name of the perpendicular be PM. We have drawn a perpendicular. Now what we do, from P let us draw another perpendicular Q. Where we have drawn this perpendicular? We have drawn this perpendicular on OR1. From where we have drawn? From P. Then what we do, from Q let us drop another perpendicular. Suppose this is M, this is M, and this is N. Okay. Now from Q let us draw another perpendicular. Suppose this is R. Got it? This is the diagram. Now here we have to understand something. I think diagram is clear. Okay, here we have to understand something, so let us go for it. Here you see, there are two triangles. Okay, there are two triangles we are drawing. Okay, let us take a right angle triangle. Okay, because both the triangles are right angle triangle. Okay, here one triangle is OM, another triangle is, suppose this is P and this is Q. Okay, this we are considering this triangle OM, and suppose this point is S. This is S, this is S. Okay, triangle OMS and triangle PQS. These triangles we are considering. Now dear students, you see this M, this is 90 degree, and this Q, it is also 90 degree because we have drawn perpendicular. Then this angle and this angle, they are equal. Why they are equal? Vertically opposite angle. That means angle S and their angle S, they are equal. Why they are equal? Vertically opposite angles. If two lines cross like this, they are equal vertically opposite angle. So these are the two lines, they cross here. So these two angles are equal. Okay. Now here this angle is A, the measurement of this angle is A. Okay, now you see, in a triangle sum of three angles is 90 degree. Here already this angle is 90 degree, so sum of these two must be 90. Again I repeat, in a triangle sum of three angle is 180 degree. In a triangle sum of three angle is 180 degree. This is already 90, so sum of these two must be how much? 90 degree. Okay, so here as these two angles are equal, suppose this is angle 1, suppose the value of this is 1, this is denoted by 1 and this is also denoted by 1, correct? Okay, now here A plus angle 1 is 90 degree. There, suppose this is P, angle P plus angle 1 is also 90 degree. Got it? So you see, here in this triangle this angle is 90, so sum of these two must be 90 degree. This is their sum is 90 degree, their sum is also 90 degree, so they must be equal. That means A plus angle 1 is equal to angle P plus angle 1. Let us cancel angle 1 from both the sides. So what is the meaning? The measurement of P is, measurement of angle P is A, so this is also A. So P is, this angle is A. This one I want to show. This angle is A. In the book it is not directly given, okay, directly it is not explained nicely. Directly they have said that by geometry we can prove this. Okay, now let us move. We want to prove here sine of A plus B at first. This is the first formula. What is sine in a triangle? Sine means perpendicular by hypotenuse. This is the triangle. Okay, here in which triangle A plus B is there? In triangle PMO. So in triangle PMO, PM is the perpendicular and OP is the hypotenuse. Sine means perpendicular by hypotenuse. PM. And what is the hypotenuse? Hypotenuse is OP. Okay, now you see. Here in the diagram, PM means PR plus RM. We can write like this. PR plus RM by OP. We can separate also, isn't it? This by this plus this by this. That means PR by OP plus RM by OP. Okay. PR by OP plus, in place of RM we can write QN. How can we write? Because you see, these two are perpendiculars or parallel, actually they are parallel to each other. Again MN and RQ are parallel to each other. So this is a rectangle. In a rectangle opposite sides are equal. So in place of RM we write QN by OP. Actually, now I want to say something here. Actually the formula for sine of A plus B will be, in terms of the formula, what we'll get? That will be in terms of sin A cos B, like this. Okay, sin A cos A, cos A sin B will get. Okay, actually the formula I am writing here. The formula will get sine of A plus B will be sin A cos B plus cos A sin B. Actually we are going to prove this formula. Okay, so initially I am saying we are going to prove it. So everything should be in terms of sine and cos. Now sine means perpendicular by hypotenuse, cos means base by hypotenuse. So we'll look after that. So here if we write PR, we need, you see, in each ratio there should be two trigonometry ratio. That means there should be two trigonometry ratio we'll get. Here we have to make two trigonometry ratio. Here also we have to make two trigonometric ratio. From this formula only we can say, because we are going to derive it. If we write like this, it will be easier to understand. Otherwise, how can I write directly? Okay, so here you see, where is PR? This is PR. PR is in this triangle. Again the figure will be clumsy. You will see PR. This angle I am writing here. This is the measure of angle A. PR. If this angle we take, PR must be the base. R is the right angle, PR is the base, and this is Q. PR is the base. That means what we have to take, which ratio he will get. If base is there, we will get a cos. Okay, either cos A or cos B. Cos A only will get okay, because base is there. If perpendicular is there, if this is perpendicular, we will go for sine. If base is there, we will go for cos. Okay, this is PR. In this triangle you see PR is the base, so we have to take hypotenuse PQ, hypotenuse, because base by hypotenuse will get cos. Okay, now suddenly from where will get PQ? If we have divided PQ here, we have to multiply PQ. Then you can think that PQ cancel, again we are getting the same. PR is written, PR is written. We put PQ here, also we put PQ. This OP is left, let us write OP. Okay, we are moving in the right direction. Now this QN. What is QN here? You see QN is in which triangle? Again I am drawing the triangle QN. Okay, this is QN, this is QN. This is the perpendicular and it is O. This is 90 degree. Okay, in this triangle QN is your perpendicular. Okay, if we take this is A. If this is A, this angle is A, QN is perpendicular. So we need always hypotenuse, because we have to take only this ratio, sine and cos. Only perpendicular, hypotenuse, base, hypotenuse, these terms we need. QN. So here obviously we have to take OQ, because perpendicular by hypotenuse will be sine. Here we have divided by OQ, so here we have to multiply OQ. QN written, then one OQ extra put here, we have divided, so we have simultaneously multiplied here. Then OP is left to right. Done. Main part we have done. Okay, this is the proof only. This thing you have to learn. Now let us write the ratios. What is PR? PR by PQ. PR by PQ is sine of A. Sorry, this is cos of A. I am very sorry. Cos of A, because this is base by hypotenuse, cos. Then that means we are getting, initially we are getting this term, is not it? So that next term must be sin B. Whether it is true or not, let us see. Now PQ by OP. Here PQ, this is PQ by OP. Okay, here I will draw the figure. Okay, PQ by OP, so that you can understand. This is PQO. This is the figure, is not it? In that figure PQO, this both the sides PQ and OP is there. But my dear student, you see PQO, this angle is B, this is angle B. Okay, so you see there. What is PQ by OP? PQ, that is perpendicular by hypotenuse, that is sine. Sine of which angle? Sine of B. Plus, then here QN by OQ. QN by OQ, perpendicular. QN is perpendicular by hypotenuse. It is sine of what? A. Then so we are getting this term. Now this must be cos of B. OQ, you see there only we are getting OQ by OP, base by hypotenuse, so it is cos of B, cos of B. Therefore you see the proof is so easy, but the figure you have to remember. Let us write according to that formula. Okay, at first this sin A cos B plus what will write? Cos A sin B. So we have got the first formula. Is it okay? Now my beloved students, we are here to prove the second formula, that is what is cos of A plus B. Actually I am writing the formula initially so that it is easier to derive it. Okay, the formula will be cos A cos B minus sin A sin B. This is the formula. This formula we are going to derive. So let us go for this. And the diagram is same diagram at whatever we have taken for the first one, that is of sine of A plus B. Okay, so cos of, this is easier, okay, because you understood the diagram. What is cos in a triangle? Cos means, now where is A plus B? A plus B is in this triangle, that is in triangle PMO. Cos means base by hypotenuse. So in triangle PMO, okay, I am drawing the figure triangle here. Okay, this is PMO. This angle is A plus B. So here What is cos of a plus b? Base by hypotenuse. This is because this is right angle. What is the base? Base is OM. Hypotenuse is OP. Right. Now in the figure, what is in this original figure? What is OM? OM can be written as ON this minus this. I repeat, this much means OM means ON minus MN. This means this bigger one minus smaller one. So let us write, it is ON minus MN by OP. Here what we will do, we will separate them. Okay, I think you understood this nicely. MN by OP. Okay, right. ON by OP minus, let us change this MN. As MN QR is a rectangle, so opposite sides are equal, so in place of MN we can write QR. Let us write QR by OP. Okay, now here in the last question also we got this type of statement, but there were plus, but here it is minus. Now we have to get here cosAcosB. So here we have to frame cosAcosB minus sinAsinB. Now cosA we have to get two terms, minus here also 2 ratio. Here we will get 2 ratio minus here also we have to get 2 ratio. Let us make the format. Okay, at first cos of a, ON. Okay, this is the base. I am drawing the triangle here. This is ON and that is Q. This is angle A. So here we have to get cos. Okay, this is the base. How will get cos? Base by hypotenuse. So if we put ON is the base, so hypotenuse is OQ. Here we have divided by, OQ. This is OQ. We are dividing by OQ. So we have to multiply by OQ. So ON we have written, OQ we have divided, we have multiplied, then OP is left. OP. Then QR. Let us write QR. Okay. And OP will be here, is not it? We have to sum one side, we have to divide here, then same thing we have to multiply here. What will be that? Sin A sin B. Now QR, where we will get QR? QR is in the smaller triangle. QR. Okay, QR here. So R is right angle, this is P, this is Q. Okay, because this angle is A, this is right angle. Okay, we have just rotated the triangle. QPR in this way we have considered, so that this comes at the base. Why we have rotated? Because this should come at the base, so that it is easier to find the ratios. So QR is there. QR is, you see in the diagram, this QR is perpendicular. We need hypotenuse to get sine. Perpendicular by hypotenuse. What is the hypotenuse here? PQ. So here we shall divide by PQ, again we shall multiply by PQ. So here ON by OQ, ON by OQ, base by hypotenuse, it is cos of A, then OQ by OP here. Okay, I'll draw another triangle here. OQ by OP, OQ by OP, OQ. So this angle is B in this triangle OPQ. This is B. Okay, this angle is B. So here you see OQ, this base by OQ by OP, base by hypotenuse is cos of B minus, then QR by PQ. We should get sine now. QR here, look at this triangle. Okay, QR is perpendicular. QR by PQ, perpendicular by hypotenuse, is sine of A. Then here PQ, there PQ, we need PQ by OP, perpendicular by hypotenuse. It is perpendicular by hypotenuse is sine of B. Thus we have proved cos of a plus b is equal to cos a cos b minus sin a sin b. Understood? My beloved students, we will prove the third formula for a plus b. Third formula is for tan of a plus b. Okay, this formula let me write at first. It is tan of a plus tan of b 1 minus tan a tan b. Okay, actually this derivation we can do without the help of this figure also. Actually we'll do without the figure. Okay, so what is we have? What is tan of a plus b? Tan means we have got one formula or identity. Tan means sin by cos. So as it is tan of a plus b, so we shall write sin of a plus b cos of divided by cos of a plus b is equal to, let us expand this. What is sin of a plus b? Sin a cos b plus cos a sin b, then cos a plus b cos a cos b minus sin a sin b. You have to learn this formula, there is no other way. Okay, now what we do, suppose it is like this. Suppose 6 plus 7 divided by 3 minus 2. Suppose just we have taken any arbitrary number we have taken. Okay, we can divide both numerator 6 plus 7 by suppose 5, 3 minus 2 by 5. We can divide here also. What we will do, we shall divide each numerator and denominator by this term cos a cos b. Sin a cos b plus cos a sin b divide what by what we will divide? Cos a cos b. Cos a cos b minus sin a sin b divided by cos a cos b. Okay, so here also if we divide, we can separate also. 6 by 5 plus 7 by 5, 3 by 5 minus 2 by 5. We can divide, we can separate. Here also let us separate them. So at first like this we shall write sin a cos b divided by cos a cos b, then plus cos a sin b cos a sin b divided by cos a cos b. Then here what will get? Cos a cos b divided by cos a cos b. Same thing, isn't it? Cos a cos b minus sin a sin b divided by cos a cos b. Like that we have done here. Okay, we are very close to finish it. Okay, here you see this cos b will get cancelled. What is this? Sin a by cos a. Now what is sin a by cos a? It is tan a. Plus here you see, here cos a will get cancelled. Now sin by cos, sin b by cos b is tan b, tan of b. They are same, they will cancel each other. It is 1 minus. Okay, then here we cannot cancel anything here, you can see. So here sin a by cos a, it is tan a. Then sin b by cos b is tan b. You can check, thus we have derived. Okay, let us write the formula now. Therefore last conclusion, tan of a plus b tan a plus tan b divided by 1 minus tan a tan b. Okay, now let us move to the formula for a minus b, or the subtraction formula. Okay, now my beloved students, we are in the next topic. That topic is trigonometrical ratios of a minus b, or the subtraction formula. Okay, here that means we have to derive the formula for sin of a minus b, cos of a minus b, and tan of a minus b. Okay, at first let us draw the figure. For this, again, for the sake of simplicity, let us draw the figure in the first quadrant only. This is the x-axis and this is the y-axis. This is y and this is y dash, and this is the origin. Okay, now let us choose a rotating arm or rotating line. Okay, it rotates like this. Okay, it rotates with respect to this x-axis, it rotates like this. So in the anti-clockwise direction, this angle is A. Then suppose, okay, let us put a name here, R1. According to the book, I am marking here. Okay, now it is rotated through an angle A. Then from this arm, another arm rotates clockwise, that is backward. Okay, suppose it rotates like this, R2, correct? It is in this direction. Again, I am discussing this. An arm, it rotates in the anti-clockwise direction. Angle made here with respect to x-axis is A. Then from there, from this OR1, another ray moves backward, that is clockwise direction, through an angle A minus through an angle B. Now this angle is our, you see, this is A and this is B. If we subtract, the smaller angle is A minus B. We want to find this angle. Now where we choose a point, arbitrary point, where we have to find the required angle. In the last figure, in case of A plus B, okay, we choose a point here. Okay, you can remember, we choose a point here because in this arm A plus B was formed. Okay, here A minus B is formed in this arm. So here we choose a point. Suppose this point be P. Then what to do? At first we drop a perpendicular to the x-axis. This is suppose M. Then next what we do? We draw a perpendicular here on this arm. Okay, suppose this is Q. Then what we do? Then from there again we draw a perpendicular. Suppose this is N. Okay, next, this is not completed, the figure here. What we do? We produce this line MP in this direction, upward. How much will produce? From the point Q, we draw a perpendicular. Okay, this is perpendicular. This line is perpendicular. Okay, suppose this point is R. Got it? This is the figure. So here again I am saying an arm OR rotates through an angle A. From there we rotate A and another arm backward through an angle B. This angle is A minus B. We choose a point, arbitrary point. From there we draw a perpendicular. Okay, this point is P. Okay, it looks clumsy, so let me give the point P, name B here. From P we draw a perpendicular to x-axis. This is PM. From P we draw a perpendicular PQ on OR1. From point Q we draw a perpendicular QN on the x-axis, and this is also perpendicular drawn, and it is produced backward. Okay, all right. Now we want to find A minus B. Now you see, if these two lines are parallel, then these angles are equal, isn't it? Because they are corresponding angle. So here this line, okay, you assume, suppose this is QR and this is OX. Suppose this is like this. These two lines are parallel. So this angle is A, so this angle is also A. This is A. Got it? This angle is A. They are parallel. OX and QR are parallel. So this is transversal. OR1 is transversal. Okay, OR1 is transversal. So this angle and this angle, they are equal because corresponding angle. Okay, now you see here this is perpendicular. Now also PQ is perpendicular to this. That means here if I take this is 1, that means A plus angle 1, this name of this angle is given as 1. A plus 1 is 90 degree. Is it okay? Because this is perpendicular. If it is perpendicular, it is always going to be 90 degree. So A plus 1 is 90 degree. Again, this angle. Okay, this plus this. Suppose that is P. Angle P in this triangle, PQR. R is already 90 degree. Sum of three angles is 180 degree. So these two must be 90 degree. Okay, P plus angle 1 is 90 degree. Now dear students, you see, each their sum is 90, their sum is also 90, so they are equal. A plus angle 1 is equal to angle P plus angle 1. Let us remove angle 1 from both the sides. That means what is the measure of angle P? It is A. That's why this angle is A. It is A. Okay, now with this deduction, let us proceed. At first, we are going to find what is sine of A minus B. Okay, what is sine of A minus? Sine means in this triangle, in which triangle we get sine A minus B? In triangle PMO or POM. Okay, let me wrap this. Here you can see that this is PMO and this angle is A minus B. A minus B. So what is sine of A minus B? Perpendicular by hypotenuse, PM by OP. Now if you look at the figure, what is PM? PM can also be written as RM minus PR. This distance is equal to bigger one minus smaller one. Suppose that is RM minus RP divided by OP. Okay, so we can separate them also. RM by OP minus RP by OP. Okay, now here RM, in place of RM, in place of this RM we can write QN, because you see this is a rectangle. Already in the first figure we discussed these two sides are parallel, these two sides are parallel, each angle is 90 degrees, so this is a rectangle, so opposite sides are equal. So in place of RM we can write QN by OP minus RP by OP. Now dear student, what we are going to prove? We are going to prove that sine of A minus B, here I am writing sinAcosB minus cosAsinB. Got it? Okay, now so here every case we need sine and cos. Sine means perpendicular by hypotenuse, cos means base by hypotenuse. So we'll look after this base and hypotenuse, okay, or perpendicular and hypotenuse. Now this each term is a product of two ratio. Each term is a product of two ratio. So here also, like the first case we will do here. So Qn by something into another ratio, here it will be OP. This is our structure. Okay, in the easier manner I am doing so that everybody can understand this OP. In this structure we will frame it. Okay, now what we will get, what we have to write, same term we have to write, isn't it? Now what is that? At first we need sine of A. Sine of A. So now QN is in which triangle? Okay, let us draw the triangle. This is QNO. We need sine of A. Here QNO, this angle is A. So we need sine A. Sine means perpendicular by hypotenuse. This side QN is there, so we need only OQ, because OQ is hypotenuse. As we put OQ here, there also we have to put OQ. This is done. Now here, okay, first part is done. Second part, cosAcosB. So here cos A, RP. Okay, let us draw that triangle. Okay, let us rotate that triangle. Okay, here angle R is 90 degree and base angle is P. Its measure is A. What is the name of the triangle? PQR. PQR. Okay, so as we need cos A, cos means base by hypotenuse. What is the base? RP is the base. What is the hypotenuse? PQ. As we put PQ here, there also we have to put PQ. Got it? We are very close to finish it. Okay, now in this triangle you see what is QN by OQ? It is sine of A into OQ by OP. OQ by OP. Okay, so this is the triangle. I am drawing the triangle here again. I am drawing each triangle individually so that you can understand. Here Q is 90 degree, this is 90 degree, and this is O, this is its measure is B, and PQO. Okay, you see in this triangle we are considering. If you do not understand, PQO. Okay, this smaller one. Okay, here we have drawn so that you can understand easily. What is OQ, base by hypotenuse. Base by hypotenuse is cos of B minus RP. You see here, RP base by hypotenuse. Base by hypotenuse is cos. Cos of which angle? A. Cos of A. Next, PQ by OP, perpendicular by hypotenuse. It is of course sine of this angle, sine of B. Therefore, we have proved sine of A minus B is equal to sin A cos B minus cos A sin B. Have you understood this? Now, my beloved students, we are in the second formula of the subtraction. Okay, second one is, I will write the formula. Okay, cos of A minus B. It is cos A cos B plus sin A sin B. You have to remember the formula. You have to memorize the formula. Just you remember, in case of cos A cos B plus, if it is minus, here will be plus. If it is plus, it will be minus. Cos A cos B sin A sin B. If it is, only problem is with the differ it in the sign. If it is minus, it will be plus. If it is plus, it is minus. Only that much. Okay. So here we are going to derive here. So cos of A minus B. So we have, what is cos of A minus B? Cos means in a triangle. Cos means base by hypotenuse. So in which triangle A minus B is there? Let us draw that part. Okay. So it is PMO. This PMO. This angle is A minus B. Okay. So cos means base by hypotenuse. OM by OP. Now, here you see what is OM in this figure, in the main figure. What is OM? OM, we can say it is the sum of ON and MN. Okay. So this is ON plus MN, or NM also you can write, your wish. Let us separate them. ON by OP plus MN by OP. Okay, now always remember one case, always we have to do that, we have to substitute here in all the derivation. What is MN? MN is the just opposite of it, QR, because that is a rectangle. NMRQ is a rectangle. So this is in place of MN, let us write QR because they are equal. Now again, what is the next thing? Next thing is that we'll make ratios. Okay, there will be two ratios, this into this plus another ratio into another ratio. Okay, so here what will be there? ON, and this is our format, we know it. Okay, we are very much familiar with it now, how to do, what to do. Okay, now same side we have to put here, also same side. Now what is that? At first we have to put cos of A. Now ON, let me draw the triangle. This is ON, base is ON, this angle is A. Okay, ON, this angle is A, and that is Q. Okay, because we have to find cos of A. Cos of A means base by hypotenuse. What is the hypotenuse here? OQ. So OQ we have to put. As we put OQ here, there also we have to put OQ. Now let us come to this. Here we have to get sine of A because QR is there. QR. Okay, let us draw the triangle again. We have to rotate this triangle always, is not it? R is right angle and P will be here base angle because this is A. What is the name of the triangle? PQR. PQR. My dear students, you see here QR is there. QR is perpendicular. We need sine. Perpendicular by hypotenuse. What is the hypotenuse? PQ. So if we put PQ here, there also you have to put PQ. Okay, right. Now in this triangle, base by hypotenuse is cos. Cos of which angle? A. Cos of A. Into, okay, we will not put into, it is understood that there will be into. OQ by, this is OQ by OP. Let us draw the triangle. O, this is OQP. Okay, this Q is 90 degree. Okay, and this is O, and what is the name of the triangle? OPQ. OPQ, this is 90 degree. At O, You see, this is the triangle. You can see OPQ. This angle, small angle is B. This angle is B. What is there? OQ, base by hypotenuse. It is cos. Cos of which angle? B. Cos of B plus. Okay. Then this QR perpendicular by hypotenuse. QR by PQ. This is sine of A. Sine of A. And here again PQ. Where we will get? Here. PQ, not this triangle, here, sorry, here we will see PQ by OP, that is perpendicular by hypotenuse. Perpendicular by hypotenuse is sine of B. Thus we have derived, therefore cos of A minus B, what we have derived? Cos of A cos of B plus sine of A into sine of B. Understood? Next we will move to tan of A minus B. Okay. Now my beloved student, the third formula here, it will be that of tan of A minus B. Do you know what it is? It is tan of A minus tan of B divided by 1 plus tan A tan B. And again, just like in the addition formula, here also we do not need this figure. Okay, directly we shall start the derivation. What we know? We know that what is tan? Tan means sine by cos. Let us write that. Tan means sine by cos. Sine of A minus B divided by cos of A minus B. Okay. Now let us expand it. What is sine A minus B? Sine A cos B. Sine A cos B minus cos A sin B. And just now we have derived what is cos of A minus B? cosAcosB, cosAcosB plus sin A sin B. Okay. Now dear children, just like the addition formula, whatever we have derived in tan of A plus B there, what we did? We divided each term by this one, isn't it? Again I am repeating, each term should be divided by cos A cos B, then only we will get this. Let us divide each term. Okay, sin A cos B divided by this term cos A cos B minus cos A sin B divided by this same thing cos A cos B. Again this is cos A, this is very simple thing, cos A cos B divided by cos A cos B plus here it is sin of A sin of B divided by this cos A cos B. Okay, if you didn't understand, actually in the first case also, that is tan of A plus B, I have discussed this. Suppose there is 7 minus 5 3 plus 2, it is given. We can divide each by any number. Suppose if we wish, it is 7 by 4 minus 5 by 4 3 by 4 plus 2 by 4. Actually we get this by this 7 minus 5 by 4 3 plus 2 by 4. Each numerator denominator we divide by same number. Okay, then we can separate them like this: 7 by 4 minus 5 by 4 3 by 4 plus 2 by 4. Now the last line. Okay, you see here, this cos B will get cancelled. Sin A by cos A is tan of A, this minus sign. Then here cos A will get cancelled. Sin B by cos B is tan of B, this will get cancelled. This is 1 plus sign. Sin A by cos A tan A, sin B by cos B is tan of B. Thus we have derived the formula tan of A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. Got it? My dear beloved students, now we will deduce some important relation. That's the topic is 2 important deductions. Here we shall deduce a relationship in sin A plus B into sin A minus B, and another relation of cos A plus B into cos A minus B. Let us deduce that. Okay, first one, sin of A plus B, Sine of a minus b. Okay, what is sine of a plus b? Sine a cos b plus cos a sin b into what is sine a minus b? Sine a cos b minus cos a sin b. Okay, the formula is very simple. In case of sine a plus b, sine a plus b, sine a cos b, and this reverse order cos a sin b. Here sine a cos a, cos b sin b, sine a cos b plus cos a sin b. If it is plus, it is plus, and it is minus, it is also minus. Okay, now you see, this is of the form a plus b into a minus b. So the thing is, it is a square minus b square. This is a square minus b square. Okay, a square minus a plus b into a minus b. So this is a square minus b square. You see, these are same, a b b square minus b square. Okay, so it is like this. AB square means a square b square. So it is also a square sine square a cos square b minus cos square a sin square b. My dear student, if sine a square is there, it means it is sine square a. We never write like this. We do not write like this, or even we do not write like this also. These are two wrong way. Here in this manner also only we have to write. Now first relation we want to find in terms of only sine. So if we want to find in terms of sine, so that means here cos must be removed. What is the relation we know, formula or the identity? Okay, here sine square theta plus cos square theta is equal to 1. So if we want to replace cos square means cos square theta means 1 minus sine square theta. So in place of cos square b, we shall write 1 minus sine square b. If it is b, this must be b. We want to remove cos, is not it? So cos square is 1 minus sine square. 1 minus sine square. It is a, so this must be also a. This is sine square b. Okay. Now let us multiply. What we will get? Let us see. This is sine square a minus sine square into 1 sine square a, sine square a into sine square b. So this is sine square a sine square b minus 1 into this sine square b minus plus sine square a sine square b. You see, we can cancel these two, equal and opposite. So the relation is sine square a minus sine square b. Okay, so we have got this is 1, suppose first relation, that is sine of a plus b into sine of a minus b equal to sine square a minus sine square b. Also this sine of a plus b sine of a minus b, what we have got just now, we have got from here sine square a minus sine square b. Now we want to get a relation of, or in terms of, this is in terms of sine, we want to get a relation in terms of cos. So now what is sine? From this relation, sine means sine square theta is 1 minus cos square theta. So sine square means 1 minus, if it is a, so we shall write cos square a, 1 minus cos square a. If it is b, we shall write 1 minus cos square b. Let us remove the bracket. 1 minus cos square a minus 1 minus plus cos square b. 1 will get cancelled. So this is cos square b minus cos square a. Got it? So this is the second relation. We have to memorize both of these. In the product of sine a plus b into sine a minus b, it is sine square a minus sine square b. But in terms of cos, it is at first cos square b minus cos square a. So you have to remember all this. Okay, let us move to the second reduction. After this, now let us move to the second reduction, that is of cos, in terms of cos of a plus b and cos of a minus b. So what is cos of a plus b and what is cos of a minus b? You know it. Let us write it down. That is product of these two we have taken, and we want to find a relation. Okay, cos of a plus b, this is cosAcosB minus, if it is plus it is minus, sin a sin b. Then cos a minus b, cosAcosB plus sin a sin b. Okay, you see, cos a plus b, cosAcosB plus then minus sin a sin b, cos a plus b, cosAcosB minus sin a sin b, cos a minus b, cosAcosB plus sin a sin b. In a beautiful manner we can learn it. Okay, now again you see, this is in the form a minus b into a plus b. What is this? A square minus b square. A square minus b square. Sorry. A square minus b square. Okay, again you know it, how we write a b square means a square b square. So we shall write like this, cos square a cos square b minus sin square a sin square b. Okay, let us write this term same as it is. We want to remove sin. Okay, let us see what happens. What is the relation? Sin square a plus cos square a, in terms of a we are writing, is equal to 1. So if it is sin, we want to replace sin. So sin square a means 1 minus cos square a. Okay, so this sin square a means 1 minus cos square a. And sin square b means, if it is b, it is b. Okay, here we are writing this is b. Okay, so it is 1 minus cos square b. Let us multiply here. What it is, same thing we'll write, cos square a cos square b minus, we'll take the help of bracket because there is minus sign, 1 into this 1 minus cos square b minus cos square a into 1 cos square a minus plus cos square a cos square b. Okay, let us remove the bracket. Minus 1 minus plus cos square b minus plus cos square a minus cos square a cos square b. These two will get cancelled. Okay, so it is cos square a, this cos square a we have written, and here what it is, you see, here I want to explain. Okay, I will explain. From these two, let us take minus common. Here only you can understand. If minus is common, 1 minus cos square b. Okay, here this, from these two we have taken minus common. There is minus 1 common, so 1 will be left. From plus we have taken minus common, so sign will get changed. It is plus cos square b, so it is going to be minus cos square b. So here cos square a minus, what is 1 minus cos square b? Sin square b. Got it? This is one of the relation. Also, this cos of a plus b cos of a minus b is equal to, okay, what we want to do, we want to change it again. What is cos square a? From here, what is cos square a? Okay, relation is sin square a plus cos square a is equal to 1. What is cos square a? 1 minus sin square a. So this is 1 minus sin square a minus sin square b. Sin square b is 1 minus cos square b. 1 minus sin square a minus 1 plus cos square b. Okay, 1 will get cancelled. This is cos square b. This one we have written minus sin square a. Now you see, in the beautiful manner you can remember or memorize this. Cos a plus b into cos a minus b. At first cos square sin square, cos square sin square. If it is a, it will be b. If it is b, that is a. Okay, just you interchange. Cos square sin square, cos square sin square, into both minus, cos square minus sin square, cos square minus sin square. If it is a, it is b. If it is b, this is a. Okay, my beloved students, here we have taken the topic now, relations between the sums and the product of the trigonometrical ratios. Okay, this is a wonderful topic. Here we know that sine of a plus b is equal to sin a cos B plus cosA sin B, and sin of A minus B is equal to sin A cos B. Then if it is plus, it will be minus cos A sin B. Okay, what we do? Let us add them. Let us add them. So what we'll get? Sin of A plus B plus sin of A minus B is equal to, you see, they will get cancelled. They are equal but opposite in sign, so they will cancel, but they are same. Sin A cos B, sin A cos B. So this is, if we add, we'll get twice of sin A cos B. Got it? Okay, have you understood? Now let us consider, let here A plus B be C and A minus B is equal to D. We consider in this way. Now let us solve for A and B. Let us do it in the rough. Here A plus B equal to C and A minus B equal to D we have considered. What we do? Let us adding, just like the solving linear equation in two variables. So if we add A plus A twice A, C plus D. So what is A? A equal to C plus D by 2. And again, this is C, this is D, or directly if we substitute there also we can get. Our main thing is that how to solve. Now let us subtracting minus plus minus. A will get cancelled, twice B, so this is C minus D. So what is B? C minus D by 2. So by solving A and B, we got that A equal to C plus D by 2 and B equal to C minus D by 2. Okay, so therefore what we get from here? Sin of, this is A plus B means C, and that is sin of D. Sin C plus sin D equal to twice of sin. What is A? We have solved. A means C plus D by 2 and B means C minus D by 2. Is it okay? Now what we do next? Again, this is done. Okay, this topic is done. Now let us subtract. Sin, again same thing let us write. Okay. Okay, let us subtract it now. Initially we added, now we will subtract. If we subtract, I will write sin A plus B. Okay, if we subtract, sign will get changed. This is minus, this is plus. So sin A plus B minus of sin of A minus B. And if we subtract, they are equal and opposite, they will cancel each other. So this is plus cos A sin B, again plus cos A sin B. So this will be twice of cos A sin B. Now let us substitute sin. What is A plus B? A plus B we have considered C. Sin C minus sin D. This is D. Cos. What is A? C plus D by 2 sin C minus D by 2. Dear student, these two are very important relation. Here you see. Thing is that how you remember? Sin C plus, this is sin C plus sin D. No need to remember all this. Our main thing is here, this part only. Sin C plus sin D, sin C minus sin D. Whenever there is sin C plus sin D, twice, in both the case twice. If there is plus, it will start with sin. If it is minus, it will start with cos. Sin cos, cos sin. Sin of C plus D by T, cos C minus D by 2. Sin C minus sin D, twice of cos C plus D by 2, sin C minus D by 2. The angles are same, only sin and cos will be interchanged in this case. Okay, at first sin cos, here you see C plus D by 2, C plus D by 2, C minus D by 2, C minus D by 2, sin cos, cos sin. Okay, in this way you have to memorize. It depends on you how you memorize, but thing is that you have to remember this formula. Okay, now dear students, we have got the relation like sin C plus sin D and sin C minus sin D. But what we will get if these are in terms of cos, that means cos C plus cos D and cos C minus cos D. Let us look at this. We have cos of A plus B cosAcosB minus sinA-sinB, and cos of A minus B is cosAcosB plus sinA-sinB. Okay, what we do initially, just like the previous one, what we did, we adding. If we add, we will get, if we add this, what we will get? Cos of A plus B plus cos of A minus B. Okay, now they will cancel each other because equal and opposite, so the sum is twice of cos A cos B. Okay, now let us consider, let, just like the previous one, A plus B equal to C and A minus B equal to D. In this way we consider, okay, just like the previous one, and then we solve here. Okay, that's why I did not rub. Okay, you may think why this part is here, because this is needed. Here if we take A plus B equal to C and A minus B equal to D, then if we solve for A and B, A equal to C plus D by 2 and B equal to C minus D by 2. So therefore what we get, okay, now let us write solving A equal to C plus D by 2, B equal to C minus D by 2. Therefore cos of A plus B means C, cos C plus cos D equal to twice of cos A means C plus D by 2, and that is cos of C minus D by 2. Is it okay? Then, okay, this is done. Next, what we'll get if we subtract? Okay, let us write here again, cos of A plus B. What we have to do now? We have to subtract. Subtracting. Okay, this minus this, cos of A plus B minus cos of A minus B. Now if we subtract, sign will get interchanged, is not it? So you see, cosAcosB minus cosAcosB, this will get cancelled. So we have to add them, but both are negative. So minus of twice sin A sin B. So let us substitute. A plus B equal to C minus cos A minus B equal to D minus 2 sin. If we solve for A and B, A equal to C plus D by 2, then sin C minus D by 2. You can remember this formula in this way, or this formula can also be written like this. It depends on you. We want to keep this or bring this minus here. How will write? You see, twice sin C plus D by 2. You see, we know it. Sine of minus theta is how much? Minus sin theta. So if we bring this minus here, that means like this. We are moving in this way. If it is like this, sine of minus sine of C minus D by 2. This is this term. Here we are not doing anything. Minus of sine C minus D by 2. So it will be sine of minus of C minus D by 2. That is sine of minus plus D minus C by 2. Okay. So we can write sine of D minus C by 2. In this way also we can derive. So here basically we have got, what is the main thing? We have got these two formula. Okay, so we have got the formula for sin C plus sin D. Okay, sin C minus sin D. Then we have got here cos C plus cos D. Then we have got cos C minus cos D. Okay.